For number 1, what we're trying to figure out is f of k. So k is negative 2 here. And to figure that out, we're going to use the remainder theorem and synthetic division. Now, synthetic division is a division shortcut that only works when you're dividing by x minus a number. So it needs to be a binomial like this, 2 terms, x minus a number. And I know this says plus, but it's x minus negative 2. To write that more simply, we just write plus 2. And that's why we're using a negative 2 in our synthetic division. K is negative 2, x minus negative 2. If you're dividing by anything more complicated than a binomial, if it has an x squared or an x cubed or something like that, you cannot use synthetic division. Synthetic division only works in this special case when it's x minus a number. And so we're going to use synthetic division to divide this polynomial by x plus 2 here. So we put the negative 2, and then we write all the coefficients of the polynomial. Just copy them down. And the first step is to just bring down that original coefficient, or the first coefficient here. And now from here on out, we're going to do the same step over and over. We're going to take the negative 2 times 4. That gives you a negative 8. You write it underneath the next number here, and then you add those numbers up. And they add up to negative 14. And then do the same thing. So negative 2 times 14, that equals a positive 28. You write it here under the next number and add them up to a 23. Negative 2 times 23 is a negative 46. You write it under the next number, add them up, and you get a negative 33. And this last value you get here is the remainder. So if we take this polynomial and divide by x plus 2, we get a remainder of 33. And what the remainder theorem tells us, this is on page 323, it's in section 3.2. The remainder theorem tells us that the remainder is equal to f of k. And you can test that. If you plug a negative 2 into this function here, the answer is negative 33. It's the same answer you get as the remainder when you divide.